Okay then, now that we're ready to move on to our ZE testing, our live working at the rest of our live working at the origin of the... Okay, now that we're ready to move on to the rest of our live working at the origin of the supply, we're going to have to disconnect the earthing conductor going into the main earthing terminal down here, okay, so that we can carry out a ZE test on the installation, okay. Now obviously prior to disconnection, one of the things we should do, again with the installation isolated, or the installation shut down as opposed to isolated yet, we get our current clamp meter, and again we clamp all of the conductors going in and out of the main earthing terminal to see if we have any current flowing. You'll see that it's all dropping back down to either 0.00 milliamps or 0.1 milliamps. So now that we have that checked, the next thing that we're going to do is we are going to disconnect the earthing conductor from the main earthing terminal. So that earthing conductor gets disconnected. Now you can use a tool to remove that. I'm standing here on a big mat, I'm not touching any other exposed or extraneous conductive parts. The cable's insulated, so I'm quite comfortable disconnecting that, but you might need gauntlets, you might need pliers, things like that to remove it, if depending on what your risk assessment says. Okay. Now that I've got that disconnected, one of the next checks that I'm going to do is I'm going to take my wee wand, my non-contact voltage detector, and I'm going to put it onto my incoming side of my main switch to prove that it's working. I'm then going to place it onto the conductor that I've just disconnected and the main earthing terminal. Remember, this part of the installation might be alive because of currents are circulating here, or this conductor might be alive. So I'm happy that I've got less than 90 volts, because that's what the lower limit of this 90 volts AC, that's what the lower limit of this wand goes to. Okay, so now that I'm there, what I'm going to do is I'm going to clamp my leads onto the meter, from the meter onto the disconnected earthing conductor. Make sure I get a good solid grip. I'm going to clamp onto the neutral terminal, and then I'm going to set my meter to LPE and it's on Z. At this point I'm going to take my probe and I'm going to stick it into the line 1 connection. Now you'll see there this meter auto tests, so it told us we had 239 volts there, okay? And we're looking for the ohmic value that we get on the screen. So you'll see there we have 0.27 of an ohm. Now this meter, you'll see there when we turned it on, it went to 3 lead low. Okay, the reason we're doing this 3 lead low is because upstream from this board I have 100 milliamp RCD. Okay, so if I did it on a high current test, I would trip out the RCD. Normally, main incoming supplies, you would be doing it on a high current test unless your risk assessment states otherwise. When we do it in a high current test, we are dumping 18 amps down the earth path. We are stressing that earthing conductor. Okay, so normally we would then just carry on with our tests. So we're going to line 2 up to 240 volts there. .21 of an ohm this time. Line 2 off, line 3 on. So you'll see there that's us, we've now ran through the 3 line conductors, just testing purely the earthing conductor for ZE. Now remember, I'm not touching any other exposed or extraneous conductive parts. You might need to use transparent screening, shrouding, things like that to make you a wee bit safer. I've got a big rubber mat under my feet here as well. Okay, so we've 0.23 of an ohm. Now again, high current testing, we would repeat this process. Again, we're looking to see what impact that those 18 amp dumps of current down the earth path have on our earthing conductor and its connections. So we're just stressing all the connections between that crocodile clip all the way back through to either the service head or the centre point of the transformer. So that's 0.23 of an ohm. 0.22, 0.22 of an ohm, and then line 3. Obviously this test takes quite a bit of time when it's on a low current setting. The one test I would say never to use is a 2-lead low current test. A 2-lead low current test, it takes forever and the accuracy of the readings is a mile out. If I didn't have this RCD upstream, I would probably be getting far lower earth fault loop impedance values than I have here. So line 3 I've got 0.21. So take those 6 values and I would pop them into a wee table and I would identify the highest of those values, and I would record that as my ZE for the installation. Okay. Now at this point, this earthing conductor down here is getting reconnected straight away.